Welcome everyone to another Directions Mag Geospatial webinar, today sponsored by our friends at Hexagon. I'm Barbara Duke, Managing Editor here at Directions Magazine, joined by our assistant webinar producer, Lynette Qualia. If you have any questions, just drop us a note in the chat and we'll do our best to help you. We encourage you to stop by directionsmag.com and catch up on the latest news, feature articles, and of course, watch more webinars. We're standing by to take your questions. You can type those into the question box at any time during the webinar. We'll get to as many questions as we can at the end of the session today. And if you see something you like on the screen, just click that little camera button. It'll save an image for you. We are recording today, so keep an eye on your inbox following the webinar for a link to the recording, as well as a link to a certificate of attendance. We'll also be in touch with links and appreciate your help on the survey on the way out. So a very warm welcome to Chris Tweedy from Hexagon. We're looking forward to learning more about the latest with ECW and how that can help out our workflows. Chris, glad to have you with us today. Welcome.
Thank you, Barbara. Hi, everyone. Thanks for the introduction again, and thanks for everyone dialing in today. Hopefully so by way of, I guess, context, I've been actively using the ECW technology since 2002. And in the last 8 years, I've been responsible for the direction of the technology. So I'm really excited to share some of our recent developments in the area of geospatial image compression. While a technical topic, it's still pretty broad. So I've done my best to, I guess, whet your appetite across a variety of areas, use cases, and examples in the next 30 minutes. So let's dive straight in. So what is ECW? It's a unique wavelet-based compression format designed for geospatial image data. It is fast everywhere. Region of interest decoding at any scale ensures immediate and progressive display without any pyramid generation. Mosaic thousands of files down to just one. Encoding is also extremely fast and simple to perform as demonstrated in this video. It's small. Our variable target quality achieves around 15 times smaller output at visually lossless quality rates, whereby compression loss is imperceptible from the original. Multiband support. Many competing lossy compression types are really limited to 3-band data. ECW's grayscale, RGB, and multiband support ensures coverage regardless of the sensor or input data. It's also portable and accessible. ECW has extremely high market penetration and generally works everywhere where you need it. Use it across software applications and across mobile, desktop, server, or cloud platforms. It is one general purpose geospatial raster format for your entire organization. ECW is ideal for any producer or consumer of geospatial imagery. The more imagery you have and the larger it is, the greater benefits using ECW will provide. It will absolutely lower your current storage costs, meet or increase performance, and generally create efficiency gains across your business. Geospatial software developers are also a key market for our format. It's in our continued interest to support and encourage third-party developers adopting our format, whether it's just to read or to also write our format. The inset movie demonstrates decoding speed from a 122 gigapixel, 10 gigabyte ECW file on an entry-level laptop. Decoding is smooth, as you can see, progressive and immediate. I did scale down the video to a small area to ensure the best chance the webinar will come across smooth, but rest assured the same decoding performance will be seen all the way up to 4K display resolutions. Compression, or image compression specifically, does not mean decompression will be slow. Speaking of the relationship between compression and decompression, every raster format must optimize for one or more of what I call the 4 image characteristics. The ideal balance really depends on the circumstance, but if we focus on visually lossless, we want to maximize storage savings for negligible change to image quality, while not having a format that takes forever to create and is also slow to decode. This 4-person seesaw conveys this concept pretty well, as there is an intrinsic link between all 4. So the best example of an unbalanced storage format would be a tile cache that optimizes decompression, speed at the expense of storage, and encoding speed. Another would be storing imagery in a mathematically lossless format for fear of quality loss. however, sacrificing storage and performance for what really could be quality loss that you can't actually see in practical circumstances. These star ratings convey the general ranking of similar formats you might have heard about at equivalent image quality. There are certainly too many permutations to track in a high-level table, so consider this a general guide only. There are, of course, many more functional qualities like bit depth support or lossless support, disk I/O or access requirements that also certainly needs consideration. Generally speaking though, and certainly across my experience in the last 15 years, I am yet to see any geospatial image format consistently meet, let alone exceed the value that ECW provides. If there is one thing to remember from this webinar though, these 4 points would be it. If someone claims they have superior something, do me a favor and always ask them about the other 3 aspects. So, happy birthday, ECW. ECW actually has an extensive history now spanning 20 years. We're in our 20th year from a public release perspective. From its first availability back in what was known as ER Mapper in the year 2000, all the way through to its current widespread use across Hexagon and the wider industry. It certainly has an intriguing origin story with a sprinkling of legal courtroom challenges and acquisitions into Hexagon. But through all of this, the Australian R&D office continues active development and no doubt is answering your questions, where is Chris based out of? While in the year 2000 was more about compressing imagery to fit onto a CD-ROM drive, for instance, the challenge for efficiently storing geospatial image data continues today. ECW continues to scale with the increase in project capture sizes and frequency of capture, and I'll be showing some of these examples of meeting these challenges in a moment. Our 20-year legacy, importantly, is not one I consider as baggage or irrelevance. Rather, I'd like to think of it as an ongoing challenge to remain as relevant and adaptable as ever. And I also have a birthday surprise. Before I jump into some of these technical accomplishments, it's important to clarify a few key concepts that I'll be referring to. Gigapixels is a term I started using in 2013 as an improved way to convey relative size. Prior to this, users would generally refer to a file size, which is really difficult to compare given a dataset could already be compressed. Stating you have a 10 gigabyte TIFF or a 1 gigabyte ECW might be the same dataset. So by taking a simplified measure based on just the total number of pixels, it becomes a great base unit of measure. The format limits on the right are some technical constraints of WEPI, JPEG, and PSD formats. Of course, it is possible to create JPEG compressed datasets larger than 4 gigapixels, but only through decomposing the image into tiles as part of a container format like GeoPackage or BigTIFF. The 29 Terra Pixel ECW example is actually not a technical upper limit. Rather, it's the largest ECW we are aware of being produced with real-world data. Our technical limit is actually much higher again, but you can imagine there are very few customers producing this sized imagery. If you'd like to challenge this leader with perhaps an even larger project, larger than 29 terapixels, by all means, please contact me, and I'd be happy to award a prize of some kind. Target quality ratio at the bottom defines the output compression quality. It is similar in concept to a JPEG percentage target, however, expressed as a ratio to the uncompressed size. The actual ratio achieved is variable though, and depends on the range of data values and presence of empty areas in the input. Importantly, the encoder will always ensure quality is equivalent. So if you convert image A at 20:1 target, the output quality is comparable to a completely different image compressed at the same quality rate, even if the actual rate achieved is different. The ECW ecosystem is really driven by the core ECW SDK library. Any application within Hexagon or external embeds our SDK to enable reading and or writing our format. We do eat our own dog food as well, ensuring the same SDK that is made public is also used within Hexagon's own software. Any difference in capabilities, performance, or otherwise is always due to integration differences only. Today, I've focused mainly on GeoCompressor as our purpose-built compression application, but ERDAS Imagine and GeoMedia Image Station are also performant and far more capable as larger remote sensing and image processing packages. All three receive ECW optimizations first and should really be your first port of call looking to compress your data. In the unlikely event you are using software that does not already support reading or writing ECW, go ahead and request it because third-party support remains an important part of the ECW story or ecosystem. The list of software applications here is also not exhaustive. There are indeed many, many more. In case we have any developers who might be listening in today, we do have a variety of licensing options available, including a free license for desktop decoding. You will always be able to convert an ECW to another format. So in this way, it really removes any fear of being a locked-in format and keeps us innovating. Customers continue using ECW not because we force them to or they're forced because of somehow being tied to our format, but they use it because of the business value it continues to provide. If it didn't, users would simply convert to another format, which can yield some interesting posts on internet communities when people start to ask why the data set is now 10 times larger. Image quality assessment for lossy image compression, summed up, I'd say is tricky. Tricky because the acceptable trade-off of quality to size is often dependent on the target audience and downstream use. Data providers want to ensure any format shows off their data in the best way possible, but if users can't discern any difference, does that change your line of thinking perhaps? For precise remote sensing pixel-based analysis, sure, discarding any data is seen as a travesty, but there is a large part of the market where some loss does not impact anything at all. This is where the concept of visually lossless comes into play. At what point can I even notice the difference? So the easiest approach is to do some kind of absolute pixel difference or statistical analysis compared to the original. These tiles, for example, show the pixels in red whose value has exceeded a threshold of plus or minus 10 compared to the original. Blue shows pixels within the threshold that are considered similar. White, exactly the same. There is varied amount of change across these unlabeled image chips. The left in particular looks especially bad. Now, obviously conducting an image assessment like this via a PowerPoint slide via a webinar is certainly not a recommended approach, but now I'm showing the equivalent image data at native resolution. Can you easily see the data loss, even when it was just highlighted moments ago? Or let's flick just a couple of times. Which one do you think is ECW? So now with the chips labeled, is this surprising at all? So hopefully just with this very quick exercise, I've got you thinking about doing your own sort of blind testing or image quality assessment. There are in fact some statistical measures that do correlate with visual similarities in this space. We prefer using the structural similarity or SSIM index, and we found values higher than 0.85 correspond closely to consumers being unable to spot the difference. So with this image averaged across a much larger pool of tile samples, ECW 15:1 target achieved equivalent SSIM quality to JPEG at 75%. Excuse me. Moving on now to another area of excellence is managing corridor or right-of-way data capture. It's an ongoing challenge for monitoring assets along linear features such as roads, pipelines, etc. Usually the project orthophoto looks like this example. At the dataset extents, it looks pretty unremarkable, except when you start to look at the dimensions. Capture resolution of 20 centimeters and a project area spanning 100,000 square kilometers. The technical challenge to store this type of raster output is obvious. While the dimensions total some 2.5 terapixels, the actual data within takes up only 2% of the total. So many given this challenge would merely break the project into hundreds, if not thousands of smaller images. However, this really just creates overhead, managing not only the constituent parts, but the parent project file, pyramids, and immediately makes it less portable. I'm yet to meet anyone who says they'd rather thousands of files for a project delivery rather than just one, just because of the project shape. So ECW version 3, back in 2013, introduced an optimization we call null blocks designed to address this scenario. By providing the geometry of the project area, the encoder will tag anything outside of the polygon as null. Think of it as the difference between compressing, say, all white or black data, representing the background, which is already extremely fast, versus compressing nothing at all. So this provides variable optimization depending on the shape of the project capture area. The less null area, the less impact it will have. In this example, we can see a substantial throughput increase and file storage savings just by using this feature. Image quality, importantly, is unchanged, even though the actual quality rate differs due to this optimization. The South Africa project at 10 Terra Pixels is a 50-centimetre countrywide mosaic that has been summarised in the case study on our website last year. Like all large mosaics of this size, the challenge is ongoing to really not rest on our laurels having successfully completed it once in 300 hours, but continue to improve. Using the same input project, we can demonstrate substantial gains in mosaic and compression throughput across geocompressor releases writing out the identical ECW file. Although the gains have slowed in recent releases, the fact that we can now compress a countrywide high-resolution mosaic in less than 24 hours on commodity hardware, by which I mean no cloud computing, no clusters of machines, no splitting into tiles, means we have really solved the big image data challenge. You cannot capture this amount of data in 24 hours, but at least you can mosaic and compress it. Another example is a dataset provided by the EOX, known as the EOX S2 Cloudless Global Mosaic. It's a brilliant example. They certainly did all the hard work filtering out the Copernicus Sentinel-2 scenes, and having a purchasable geo package makes it immediately accessible. But could ECW do any better using this sample data? So there's a few things to note with this example. Firstly, the geo package has variable scale-dependent data. As you zoom in, it switches to use different derived base maps for cartographic purposes. So with ECW, it's not possible to do the same scale-dependent rendering, as ECW will only compress at dataset resolution. So this difference will really have minimal change to the output file size. Secondly, the ECW output uses our null block optimization. This involves passing in a vector multi-polygon buffered along the global coastlines to create an effective 62% filter across water bodies or the oceans. We can then set the background to a deep blue, as seen here, and no one would know. Thirdly, the output ECW was created from an already JPEG compressed geopackage source. This isn't ideal from a quality perspective because we're going from a lossy to lossy image compression, but it still serves as a useful comparison. As you can see in the side-by-side example in Dubai, quality degradation is hard to spot and still might be acceptable. Despite these 3 points, it again reconfirms the ease at which global mosaics can be created during your workday on a standard workstation using ECW, and it will be 4 times smaller. ECW decoding or decompression speed is a related topic that many continue to think must be slowed because compression. Although benchmarks are by nature focused, in this example, Hexagon's Erdas Apollo remains the most optimal delivery mechanism for ECW data by a large margin in a server environment. This chart shows that for identical benchmarks, with the only variable being the server software, Apollo is up to 10 times faster than the Esri platform, despite the ECW SDK, the ECW file, and hardware being identical. The photo on the right is also from our partner Geosystems Germany user group meeting, whose customer independently verified gains of 5 times for WMS or up to 22 times faster, taking our streaming ECWP into account. I really love seeing customers verifying these numbers. Similar to the previous slide comparing delivery servers, creating ECWs also has a widespread in terms of speed processing identical input. Depending on the application, you can see a wide gap start to form and indeed gets larger with increasing project size. Here is the earlier mosaic of 78 gigapixels. This was mosaicked and compressed from the same deflate compressed TIFFs using a variety of software production tools. The Hexagon geocompressor software advantage is clear in terms of speed. This is due really to our additional optimizations made within geocompressor to ensure input data is fed into the encoder as quickly as possible. This reading bottleneck is the limiting factor, not the compression itself. In almost all situations, ECW compression threads are starved, waiting for input to process. So perhaps this might be a hint to some of our third-party product integrations. If you are looking to create mosaics in the hundreds or gigapixel range, GeoCompressor not only maintains its lead, as shown here, but in many Terra Pixel sized projects, it's really the only product on the market capable of generating ECW mosaics in this size. Now, coming back to our birthday surprise. By context, when you consider our 20-year legacy, many of the design decisions in ECW were made for the lowest common denominator in 2000 to ensure widespread adoption. The limiting hardware of the times really forced the format to store data in very small sizes, and that was really done to ensure low memory efficiency and adequate performance from slow hard drives. A lot has obviously changed from a hardware perspective. However, the way we are storing the ECW data has not. It will soon be changing. Since the release of the version 5 SDK in 2013, the product team has been waiting for the market dynamics to catch up where we could finally address this design decision. I'm super excited to announce that starting with GeoCompressor or ERDAS Imagine Update 2, we will now be deploying these new optimizations for substantial improvements. This optimization has already been in use for 6 years for extremely large ECW files in the 2 or more terapixel range. These massive files will not see additional improvements. However, we are very excited at rolling this change back to the majority of our format users, not just those representing the small tail of the wedge. So what does this actually mean, Chris? Storage size requirements will be 10 to 20% smaller. Encode or compression speed will be almost 2 times faster in many cases. Image quality, importantly, will be identical. And decoding speed will be up to 50% faster. So I bet you're all thinking now, okay, Chris, I'm sensing there's a catch. Is this ECW version 4? Wrong. These gains have all been done with 0 format changes, which means anyone already using ECW version 3 will see these new benefits immediately on decoding or by upgrading to gain the encoder benefits. So if you're still sensing there's a catch, there is but a small price to pay. In order to implement these optimizations, compression memory requirements have increased up to 80%. And this was really the main reason we withheld this optimization from market in earlier years, as the formats needed to remain generally accessible, not just to those with an unreasonably large amount of memory available on their system. So some example project sizes are listed here. For those unaware, the larger the project, the larger the memory requirements to compress. Although 80% increase sounds like sounds substantial, in real terms, it's still very accessible for any workstations or even a laptop. And this increase impacts compression only, not reading or decompressing the file. For most users, except our very large data production customers, creating terapixel output images is infrequent. So rest assured that these optimizations will be transparent to most users, but the benefits will be immediate. So, and just to clarify the largest project listed here at 14 terapixels, the memory requirements have not changed. And again, this is because the optimizations have already been applied. As also mentioned, these optimizations have been battle tested in our extreme project sizes for some time. A sampling of our smaller test project results can be seen here. So file savings will vary. However, all sizes will see improvements, whether it's 1 gigapixel or 500. And compression speed has increased substantially. All shows gains independent of the size, band count, or bit depth. Now moving on to a more detailed side-by-side comparison. Cloud-optimized Geotiff, or COG for short, is a relatively new spin on an old, and there's nothing wrong with old, Geotiff format. It makes specific structural tweaks to the format to enable rapid retrieval in cloud environments using things like HTTP pipe ranging. This enables some unique workflows, say for example, satellite vendors to provide the data directly to customers without downloading a file in the traditional sense. COG supports many types of internal compression types, including lossless. But since we are focusing on visually lossless in this webinar, this chart shows for a small input image the output differences, creating a COG with 75% JPEG compression with all recommended tuning options enabled. A key limitation, though, of this structure is it's limited to 3 bands. This input is 4 bands. So to cover the most typical red, green, blue, and color infrared, you need to create 2 different cog files shown. Alternatively, you could use a different compression method other than JPEG that might support multiband, but then that really increases size and slows the speed significantly. Shown in green, ECW does not have this problem. We can compress all 4 bands into 1 file and support as many band combinations as required to display. So when taken in aggregate, this yields a more than 30% improvement in storage requirements at equivalent quality rates. Some back of the envelope math could quickly calculate the potential data storage requirement savings if you're already using JPEG-based compression formats. This slide is similar to previous, but for larger input using our favorite 78 gigapixel mosaic. Here again, ECW multiband offers a 32% storage improvement, or even as much as 52% if a 20:1 target produces acceptable output quality. The bottom metric is also an important consideration. Although many will claim encoding is CPU time, so it doesn't matter, if you're a data vendor with significant data holdings, spending 6 hours longer than you need to is still a major bottleneck, let alone an attributable cost if you're spinning up cloud instances to do this conversion. So while I've intentionally not gone into too much technical detail here, I'm certainly happy to when I have more time. If byte ranging is a critical need, fantastic. But this idea of streaming is also something we've supported for over 20 years using our related ECW protocol or ECWP. If you need client-side browser-based decoding, we also have a WebAssembly-based ECW decoder. Like any format, COG has its target market, but the usual trade-offs still apply. And with that, I hope that has given you a glimpse into the ECW capabilities and shows you how we continue to push the envelope at Hexagon even after 20 years. Finally, please remember to trust but verify. Perform your own image quality assessment on your own data. Question why you're using JPEG compressed at 90%, or why are you storing the same file multiple times for different applications? How much storage is all my imagery really costing me? Maybe it's time for another look at ECW, and the global team at Hexagon are eager to support you on that journey. And with that, are there any questions, Barbary, I'd like to take?
Yes, so we've got time for maybe just a couple of quick questions. The first one is, how can ER Mapper users take advantage of the newer format features?
So ER Mapper is now available and still supported under ERDAS Imagine. So ER Mapper is still being updated with the new SDK. So it kind of depends on the specific functionality you're looking to take advantage of, and I'd be happy to maybe explore more offline in terms of what you're looking for. But generally speaking, ER Mapper and Imagine will continue to use the updated SDK versions.
Okay, excellent. And you mentioned the improvements are coming in 2020 update 2. When exactly will that be available?
So GeoCompressor, actually update 2 went live 12 hours ago. So that's on the Hexagon Geospatial product download side. The ERDAS Imagine update 2 is coming. I don't have an exact date. That's obviously a much larger product, but I would expect that would be in a matter of weeks, certainly well before the end of the year. So not long, wait.
Awesome. Chris, thank you very much for your time today. We appreciate it. Encourage folks to keep an eye on your inbox. We will be in touch with the recording, attendance links, and appreciate your opinions on the survey. Special thanks to Catherine as well, who helps get these Hexagon webinars organized. We hope that you go have a great day. Tell a friend about Hexagon and Directions Magazine. Thanks, everybody.
Thanks, everyone.